All right, so 3.7 is implicit differentiation. 3.7 implicit. So a couple questions we have are number 5, and most of these are just take its derivative, and we're going to see where these are going to do for us a little bit later. We need this in order to do some word problems in not the next section, but the section after this. It's really kind of interesting on problems. So, all right. So when I want to take the derivative of this, do you see how the left side's a product? So this is an f, and this right here is a g. Okay, so I know the derivative of the first is going to be 2x times the second, which is x minus y squared, plus the first, which is going to be equal to x squared, times the derivative of the second. Well, this thing right here is a chain rule because I have this square, right? Does that make sense, the derivative of this thing? So you're going to take care of that power of 2 first, to the first power, right? Now we have to do times the derivative of what's inside. Well, what's the derivative of x? 1. And what's the derivative of y? dy dx, so minus dy dx. So that's kind of messy. It's like I said, it's a product rule where g actually has a chain rule. And then the derivative of the right-hand side, don't forget this side as well. So the derivative of x squared is 2x, and the derivative of y squared is 2y, but don't forget what? When you take the derivative of y, you have to followed by dy dx, multiplied by dy dx. And then what we have to do is we have to expand this thing completely because I need to collect all my dy dx's on one side and everything else on the other, right? So I have to get rid of all these parentheses. I'm not really pleased about that, but it is what it is. This is awful. Okay, so yeah, I recorded that. So 2x, so I'm going to have to multiply this thing. So remember, this is x minus y times x minus y. I bet you there's a bunch of different ways to solve this, but I find it easier to always do the exact same thing. Just get rid of parentheses, and then we can collect like terms, okay? So this is going to be equal to x squared minus 2xy plus y squared. That's that piece. Plus, cleaning this up, I have 2x squared times x minus y times 1 minus dy dx. I'm going to multiply this right-hand side out a little bit more. So this is plus 2x cubed minus 2x squared y times 1 minus dy dx. I'm just trying to get rid of all parentheses, okay? I'm just trying to multiply everything I can. The right-hand side's kind of good, that's why I'm kind of leaving it alone, okay? So then I'm going to get rid of all these parentheses by multiplying. So this is 2x cubed minus 4x squared y plus 2xy squared. And over here I'm going to have to FOIL. So first is 2x cubed, outside is minus 2x cubed dy dx. Inside is minus 2x squared y, and then last is plus 2x squared y dy dx. Still equal to that right-hand side. Now let's see if anything kind of collects. We got a couple nice things here. So I can see that I can pull a lot of these together. For instance, these are like terms, right? And these are like terms. And well, that's it. Okay, so the reds first. So I have 4x cubed. In the blues, the greens, I have minus 6x squared y. Yep, so those are taken care of. Plus 2xy squared minus 2x cubed dy dx plus 2x squared y dy dx is equal to 2x plus 2y dy dx. So anything that has a dy dx is going to go on the left. Anything without a dy dx is going to go on the right. So this gets to stay on the left, so minus 2x cubed dy dx. This gets to stay on the left, so plus 2x squared y dy dx. And this has to come over, so I'm going to have to change its sign, so minus 2y dy dx. And everything else is going to go on the right-hand side, so, you know, all these things when I send to the other side are going to have to change signs. So I'm going to start out with this 2x, stayed over there, and all these are going to change signs. So minus 4x cubed plus 6x squared y minus 2xy squared. Whew, messy. You guys agree that everything shares a dy dx? So you can factor that out. So dy dx, and this is going to be minus 2x cubed minus 2x squared y minus 2y. And then I'm going to divide that. So then we have 2x minus 4x cubed plus 6x squared y minus 2xy squared, all divided by that piece, and then we're done. That's it. For number 5, that's pretty impressive. Like, they came out swinging in this chapter, didn't they? Okay. Any questions? Besides just, do you guys agree it's not, like, the hard part's the derivative? Then everything else is just multiplying. You guys have multiplied before. It's not, like, none of that is hard. It's just tedious and awful, right? Like, you guys can all do it, though. But collecting like terms and solving is something you guys have been doing since the beginning of time. It's just trying to stay patient, right? Number 7. What's kind of nice is kind of Calc 1 is like the first spot where you guys notice that math being long is not really what makes it difficult. It's the long part that's not hard. Honestly, the long part usually is easy. It's just tedious. It's no fun. It's just tedious. So as you guys move through math, you'll notice that they'll get a little bit longer every now and then. Okay. So for this one, taking its derivative. So derivative left, derivative right. So I take the derivative of both sides with respect to x of y squared is going to be equal to the derivative with respect to x of this expression over here. What's the derivative of the left side? You have 2y dy dx. And when you take the derivative of the right, what rule do you have to use? Quotient rule. So derivative of the top. Derivative of the top. What's the derivative of this? The derivative of this? 0. So 1. Derivative of the top is 1. Times the bottom. Minus the top. Times the derivative of the bottom, which is 1, right? All over the bottom squared. Oh, this is great. What's nice is all I'm going to have to do in a second here is just divide by 2y. You guys see that there's no dy dx's over here? Because there's no y's over here? Okay. So let's clean this up. So x plus 1 minus x plus 1 all over x plus 1 squared. So just distributing. This 1 is meaningless, so I just distribute that. Distribute this. So the x's cancel, so what I get is I get 2 all over x plus 1 squared. And this is 2y dy dx. So what still has to come over to this right-hand side? 2y. So dy dx, so I'm going to have 2 on top and another 2y on bottom, right? So when you divide, it just goes in the bottom. So these 2's will cancel. So dy dx is going to be equal to 1 over y times x plus 1 squared. What's kind of clever here is you could actually write this derivative all in terms of x, assuming that you can square root this side. If I square rooted this side, the problem is you get plus or minus, but like if, so let's say y was equal to the square root of that expression, you could just put that in the bottom. You guys notice that? But most of the time, you know, your derivatives are going to be both a function of x and y. Okay. This is going to get a little messy. Derivative of x, 1. Derivative of the tangent of something. Of that something, right? You guys agree? You leave the inside part alone. Multiplied by what? The derivative of the inside. But be careful, this inside is two functions, right? It's an x and it's a y, right? So it's a product. So what's the derivative of the first? 1 times the second, right? Plus the first, which is x, times the derivative of the second, which is dy dx. So be careful. That comes up so often. You guys see that you have a product of x, y? So just be careful that that's always going to be a product rule. And over here, the derivative of 0 is 0. So now what I'm going to do is I'm going to get rid of all the parentheses. So I'm just going to multiply this into the secant, this into the secant. So this is going to be 1 plus y secant squared of xy. That's this piece being multiplied. And then this piece also being multiplied into the secant. So this is going to be plus x dy dx times the secant squared of xy. You guys agree, like, you can't multiply these things together besides just put them in front of each other because they're not combinable, I guess would be the best word for that. So I just write them as coefficients, write that as a coefficient. Now what's nice is this term right here has a dy dx, so I just have to isolate that term and I have to send the other ones to the other side. So x dy dx secant squared of xy is going to be equal to, sending those to the other side is just a change in sign. And then I just divide by what I don't need, so divide both sides by secant squared of xy and this x. So dy dx is going to be equal to minus 1 minus y secant squared of xy. And I'm going to divide by this x and this secant squared. All right, 37, we're going to, 37, 40, you know, I'm just going to do 37 because it's asking for a normal and a tangent. So 37 says this, we have 6x squared plus 3xy plus 2y squared plus 17y minus 6 is equal to 0. And it wants both the normal and the it wants both the tangent line and the normal line at the point negative 1 comma 0. So I'm going to put the point over here at negative 1 comma 0. So we'll call that up in a second here, this x comma y value. So first I want the derivative. So the derivative with respect to x of this entire expression is going to be equal to, well, plus the derivative of 6x squared is 12x. We have to be careful of this term right here, right? 3xy. So be careful with those, they come up a lot. So 3x is going to be your f function and y is going to be your g function, right? Because it's another product. So what's the derivative of the first? 3 times the second plus the first times the derivative of the second. You guys getting the hang of that? Derivative of the first times the second plus the first times the derivative of the second. Any questions on it? Is that clear how you take the derivative of that expression? It comes up a lot, so I really want to make sure you guys see that. Okay, the derivative of 2y squared. 4y dy dx, okay. Derivative of 17y. dy dx up 17 with the dy dx multiplied. Derivative of negative 6 is 0, derivative of 0 is 0. So the derivative of that, so that's its derivative. So what I know is I can isolate your dy dx's. So I'm going to keep these on the left, send the 12x and the 3y to the other side. And when I factor out your dy dx, I get 3x plus 4y plus 17 is equal to that side. So dy dx is equal to minus 12x minus 3y all over 3x plus 4y plus 17. So kind of the same thing we did again, right? Just put all your dy dx's on one side. So then you can factor it out. When you're done factoring it, then you multiply. I'm sorry. When you're done factoring, you just divide by that factor that's left over. Okay, so how do you find the slope of the tangent line? Well, I need to find the slope of the tangent line at the point -1, 0. So what'd you say? Yep, just plug them in. So that means dy dx is going to be equal to -12 times -1 minus 3 times 0, all over 3 times -1 plus 4 times 0 plus 17. So this is going to give us 12 all over -3 plus 17, which is 15. So they're divisible by, what, 3? 4 over 5. Yeah, there we go. Is that clear? Okay. How do you find the slope of the normal? Yep, it's the negative reciprocal of this. Does that make sense? So that would be equal to, I'm just going to write it as m, but it's going to be -5 over 4. It's the negative reciprocal of the slope. So the slope of your tangent line, which is this, derivative evaluated at the point, the slope of the normal line, the normal is just perpendicular to the tangent line. So to get a perpendicular slope, you take the negative reciprocal. So your tangent line and your normal line would be y is equal to m times x minus x naught plus y naught, right? Just plug in your point -1, 0 in for your x naught, y naught, and your slope in. The slope of the normal line would be, it's the exact same thing except the slope is a negative reciprocal, so -5 over 4 x plus 1 plus 0. So those are your two lines.